Okay, so today we're going to be looking at more derivative stuff. Specifically, we're going to look for maybe a better way to do derivatives, because as you've seen at this point, the process can be a little bit long and tedious, especially if the function looks a little bit more complicated. So what we're going to start with is a function that should motivate us. Right? We're gonna try a function where using the limit definition is a little bit long and tiresome, and hopefully that'll push us into how can we find a better way. So let's do that right now. As our warm-up, I want you to find f prime of x. Okay, so pause right now, take a moment to do it yourself, and then when you're ready, you can resume and we'll look at the answer together. Okay, so after all that, you should have gotten 12x cubed plus 10x minus 1. And I actually can look at this and tell you the answer immediately. And you might be going, what? How can you get the answer so quickly? Well, just so you know that you weren't alone, I did do the full limit, which is this thing. And it took a long time and it was messy. I didn't even have enough room over here, right? I had to put a little caret like, hey, don't forget this is part of it. But I did get 12x cubed plus 10x minus 1. I didn't need to do the limit though. I can actually go straight from here to here because the process of finding derivatives has a pattern that I'm using. So that's what we're going to look at today, is a faster way to find derivatives. And we will go over it in class what the specific pattern is, but the point of today's video is to get you thinking before we come together as a class. I want you to start searching for patterns and trying to come up with a rule on your own. So in order to do that, we're going to look at our packet. So in the packet, there's this page that says investigation. This is page 2 of your derivatives packet. And instead of asking you to find the derivative for the first 3 problems, I already give you the derivative. And what I want you to do is figure out if you see any pattern from the starting function and how to get to the derivative, right, without doing the limit. So take some time to go through these first 3 yourself and see if you can notice anything, any similarities, any numbers, right? Maybe ask yourself, where'd this 21 come from? What in my original function could have possibly gotten me a 21, right? And then check with the negative 10. You know, you can maybe ask yourself that, like, where could the negative 10 have come from? So I'll let you pause and do that on your own. And once you've kind of got a pattern, we're going to try the 4th one where you have to come up with the derivative yourself. Okay, so now that you've thought about the first 3, let's look at this 4th one right here. So we have y equals 3x to the 11th minus 20x to the 6th plus 3x to the 5th minus 12x squared plus 6. I definitely don't want to do the limit definition for this one. Could you imagine expanding something that's to the 11th power? That would get, like, I'd need so many pages to do this in my notebook, right? So based on your pattern, I want you to fill in what you think the derivative is. And it's okay if it's wrong. We're thinking right now. So whatever you think the pattern is, go ahead and fill it in. So if you need more time, pause. But I'm going to tell you what should go here. The derivative should be 33x to the 10th minus 120x to the 5th plus 15x to the 4th minus 24x. So if you got that, you're probably on the right track. And I want you to try the next one. And if you didn't get that, see if the pattern from number 4 will help you adjust your pattern. See if you can come up with a different rule. And we're going to try number 5 next. Now with number 5, we have this radical, right? Square root of x cubed. Again, something that feels not fun to do the limit definition way. But if we're trying to find a pattern, it could be easier. And in order to use your pattern, to use your rule, I highly recommend rewriting this so that it's not a radical, but a power, right? Instead of the square root of x cubed, we're going to write that as x to the 3 halves. And if you're feeling a little rusty on turning radicals into rational exponents, then maybe spend some time reviewing that this next week. So I'm going to use a darker color, but I'm going to look at this and use my rule, my pattern, to find y prime. Now, if you haven't done yet, then go ahead and pause and take a moment to write what you think y prime should be. What I got is 3x to the 1/2 minus 60x cubed. And this is a simplified answer because from your rule or your pattern, you might always have numbers that can simplify. So this is the final written version. Okay. So what I would like for you to do is think about how we would fill out the rest of this page, right? And the bottom box says power rule, which may give you a hint as to what we're looking at here. And if you think you know what the power rule is, I want you to write a general version of it the best you can. The power rule is the pattern that we've been talking about. And so your task is to do this on your own, and then when we meet together in class, you will be sharing your results with your classmates. And then we'll go over the power rule together and finalize it. But that's pretty much it for this video. Thank you for being here, and I will see you next time. Bye.